Assalamualaikum warahmatullahi wabarakatuh. I'm making this video for the purpose of CSC159 Computer Organization course in UITM. This is Chapter 4, the CPU and Memory Design and Enhancement, Part 4, Memory Enhancement. In computer environment, memory is slow compared to the CPU processing speed. For example, if we are using 2 GHz CPU and a 70 nanosecond DRAM, the CPU can complete one cycle in half billions of a second. But the DRAM can complete one access only in 70 millions of a second. In this comparison, it shows that the DRAM works much slower compared to the CPU. Therefore, to solve this problem, the memory enhancement is needed. There are 3 approaches that can be done to enhance the memory performance. The first approach is wide path memory access. Second is memory interleaving, and the third is cache memory. These are the overview of the 3 methods of the memory enhancement. The first method is the wide path memory access. This method provides a wider path or a bigger way for the CPU to access the memory, meaning that the CPU can retrieve multiple bytes of data in the memory instead of 1 byte of data of a time. While the memory interleaving method divides the memory into several parts. Those parts has their own register, which are the address register or MAR, memory address register, and also the data register or MDR, memory data register. And lastly, the cache memory works by positioning a small amount of high-speed memory between the CPU and the memory. That small high-speed memory is organized into blocks, and each block provides a small amount of storage. As I mentioned previously, the wide path memory access allow the retrieval of multiple bytes of data in memory instead of 1 byte at a time. The widening of the path is done by using a larger size of memory data register MDR. And it is a simple technique and it is widely used in enhancing the memory access. By using memory interleaving method, the memory is divided into several parts. By doing so, the memory access rate can be increased. This is because the CPU can possibly access the memory more than one location at a time. And the most effective parts of this memory interleaving method, where each of the divided part has their own MDR and MAR. Therefore, all of the memory parts can transfer all of the data from them to the CPU simultaneously, resulting more than one data are being transferred in one time to the CPU. This is an illustration of the memory interleaving. As you can see here, there are 4 parts of memory has been divided. And each of the parts has their own MAR and MDR. This means the CPU can have access to all of 4 parts of this memory. And the CPU can fetch the data from these 4 simultaneously in one time. In Malay, dalam memory interleaving, memory dipecahkan kepada beberapa bahagian, yang mana setiap bahagian tersebut mempunyai memory address register dan memory data registernya yang tersendiri. Oleh itu, setiap kali CPU ingin mengambil data daripada memori, CPU boleh memasuki ataupun boleh akses kepada kesemua bahagian memori yang telah dipecah-pecahkan. Kalau dalam gambar rajah ini, kita ada 4 pecahan memori, maka CPU boleh mengambil data daripada keempat-empat bahagian ini sekaligus di dalam satu-satu masa. The last method of the memory enhancement is by using the cache memory. Cache memory is an extremely fast memory type that acts as a buffer between RAM and the CPU. It is placed between the RAM or the memory and the CPU. The cache memory is functioned to hold the frequently requested or frequently used data and instruction so that they are immediately available to the CPU whenever it is needed. The function of cache memory is to reduce the average time to access data from the main memory or RAM. The cache controller is a hardware that copies code or data from main memory to cache memory automatically. And the cache line is the unit of data transfer, or how many data is being transferred between the cache and the main memory. Normally, the cache line is 64 byte. And cache hit ratio is used to measure how many content of requests a cache can deliver successfully from its cache storage to the CPU. The cache memory need to be synchronized with the memory. It is done by doing the write-through and write-back process. If the synchronization is done by using the write-through method, the data is write back to the main memory immediately upon the change in the cache. But if the write-back method is used, the memory is only written when a cache line is actually replaced. This is an illustration of cache memory. The first action of using the cache memory is every memory request goes to the cache controller. Then the cache controller checks the request against each tag. The tag is actually the memory address. And if there is a hit or request from the CPU, the cache location is used instead of the memory. In BM, cache controller akan menerima memory request daripada CPU, yang mana memory request ni akan disemak ataupun dia akan dicek oleh cache controller berdasarkan tag ataupun alamat memory yang diberikan. Sekiranya request yang dibuat itu mempunyai hit ataupun kadar penggunaan yang tinggi, maka cache memory akan digunakan ataupun cache location akan digunakan menggantikan memory. Ini bermakna di dalam cache memory, semua data yang kerap kali digunakan ataupun kerap kali diminta oleh CPU akan disimpan di dalam cache instead of disimpan di dalam memory. And that's all for this chapter. See you again in other video. Thank you.